Hello, in this video we are going to show you how to determine the equation of a quadratic function using given information. And the first question is a real-world application. So a rocket is launched in the air. The graph on the right shows the h, the height of the rocket, and the emitters and the time in seconds. So question 1 asks you what's the rocket's greatest height. Also, we could say is a maximum height. So it will be at the vertex, the turning point. So this x is x coordinate is time, y coordinate is height. So the greatest height will be the y coordinate at vertex, so 765 and 0.625 meter. And when did the rocket reach its greatest height? So when is for time, so the time in seconds at vertex is 12.5 seconds. And what's the initial height? Initial height means t equals 0, so it's a y-intercept. So it's here. It's 0, 0, so it's 0 meter. When did the rocket hit the ground? Hit the ground means x-intercept, the height is 0, so it's t equals 25. So when means asking you for time, the units should be seconds. How long did the rocket in air? It is from the rocket is launched until it hits the ground. So it's from here to here. The rocket is above the ground. We call it in air. So it's 25. Take away 0, give you 25 seconds. And the last question asks you to determine the equation of this problem. So in order to find the equation of this problem, we need to know the three forms. Y equals ax squared plus bx plus c, the standard form. And the three forms, the second one is a factor form, a times x minus s, then x minus t. And the third form is a vertex form, y equals a bracket x minus p bracket squared plus q. And in this given graph, we are going to see PQ is your vertex, so it will be here. So P equals 12.5 and Q equals 765.625. And from the second one, the factor form, ST are the x-intercept. So this is 25, this is 0. And the first one, standard form, the only thing you can know it right away is the y-intercept. So C is your y-intercept, is the graph intersect with a y-axis. So this point is C equals 0. And from these three form, you will see each form you have 3 parameters. The parameters are the numbers, the values that you need to find in order to write the equation out. So the first one you have A, B, C. The second one you have AST. The last one you have APQ. So each of them have 3 parameters. And for the last two, you both have 2 given. You have only 1 unknown. And in each of these equation, you will see beyond this A, B, C, AST, APQ, you also have X, Y. So in each equation, you have 5 variables. In order to solve one variable, we need in one equation, we need 4 of them given. So the first one, we only have C, we need to have 2 unknown variables here. It will be a little bit hard to solve it, so we could pick one of the bottom two. So we are going to use a vertex form to find the equation. So we write the vertex form here, and in this equation we have 5 variables, y, a, x, p, q. So 5 variables. We want to sub 4 given into this equation. So the first one is PQ. So we have 12.5 and 765.625. So PQ are given, and also we could pick one of the point from the graph, but not the vertex. So we could put 0, 0, or we could put 25, 0 as your x, y. So now we have 1, 2, 3, 4. 4 things given, we can substitute in and solve for a value. So 0 equals y is 0, a is unknown, x is 0, p is 12.5, then q is 765.625. Then we have only one unknown, so we are going to solve it. We move the 765.625 to the other side. We are going to isolate the a value, so it will becomes minus 765.625. Then equals a times 0 minus 12.5, then squared. Use your calculator, you will find out is a times 156.25. In order to solve for a, we are going to move the 156.25 to other side by doing opposite operation. So both sides divide by 156.25. Then you will find out the a value is negative 4.9. Then we are going to write the final equation, subbing a, p, q to the vertex form. We have y equals negative 4.9 bracket x minus 12.5 bracket squared, then plus 765.625. So this is the equation for this given graph. Okay. So now we are going to see the second one. Determine the equation of a path of a rocket if its highest height is 400 meters, and I think I changed that to 503. This is 10 seconds, and the initial height is 3 meters. So this one we could write it as a PQ. So P value is time is 10 seconds, and Q value is 503. So the initial height is 3 meters, initial height 3 meters at t equals 0. So you have 2 points, and we are going to sketch it, then find the equation. So because the time will be always positive, so we could put the x and y axis, both are the positive. So I will erase it and redraw the. Okay, we are going to start from this 0, and this is x-axis, and also from here we go up as a y-axis. The reason for that is we don't have time less than 0, we don't have the height less than 0 for this question, the rocket. So, and we are going to label it x-axis. Now it's not time but in meters, or it's time, sorry. Now we are going to label the x and y, so it's time in seconds, and this one is height in meters. The initial height is 0.3, the maximum height is 503. So we are going to go by 50 on the y-axis. We need to make sure that 500 is in the grid given. Then 550. Okay, so it works. Now we are going to graph zero. So the x-axis, because 10 seconds is a maximum, so we don't want to go by 10, then we don't have other side of this graph. So we want to go by 2 on the x-axis. Okay, so 0 and 3, it will be very close to 0 point. Then the 10 and 503 will be somewhere here. So we have 2 points, and how are we going to determine this equation? So this is a PQ is 10, 503. So as long as the vertex is given, we could use a vertex form. So y equals a bracket x minus p bracket squared plus q. So we have 1, 2, 3, 4, 5 letters, 5 variables in this equation. We need to have 4 given. So PQ are given by the vertex, and the XY is given by using a point on the graph. We sub in these 4 given into this vertex form. We are going to have 3 equals a, x is 0, p is 10, and q is 503. So now we are going to solve for a. We are going to move the 503 to other side by doing opposite operation is subtraction. So 3 minus 503 give you negative 500. And a times the bracket negative 10 squared give you 100. So in order to solve for a, we move the 100 to other side by doing opposite operation. Then we have a equals negative 5. Then we sub in to the vertex form APQ. Then you have the equation for this question is negative 5 bracket x minus p is 10 and q is 503. So this is how you find the equation of a problem. So sub in PQ XY. Then you will have only one variable left. Then do the opposite operation, move the numbers to other side, isolate the a value, then you solve it. Okay. So next question is a soccer ball is kicked from a point 30 meters to the left of the center line, and lands at a point 10 meters to the right of the center line. So it reaches a maximum height of 6 meters during its parabolic flight. So it asks you to sketch a graph to show the flight of the soccer ball if the center line passes through the orange. So we need to draw the center line at middle. And after that, state some key features of the graph and find the what's the approximate height when it is 5 meters to the right of the center line. Okay, so we are going to see how we are going to graph it. So we are going to draw the center line. And also again, the soccer ball didn't say below the ground, so we are going to draw the x-axis at the bottom. So this is in meters, x in meters, and the center line is passing the middle, so we are going to draw this, the middle, okay? The center line is here. So this one we call it height. H, then the unit is in meters. So after that, we are going to label the scales. So on the left, 13 meters. So we are going to go by -5. Go by 5. -15, -20, -25, -30. So the soccer ball was kicked from the center line to the left, 30 meters. Then the soccer ball left on the right, 10 meters to the center line. And the highest point is 6 meters. So we need to find the vertex. It will be middle of these two x-intercepts. So 30 plus 10 divided by 2 give us -10. So the axis of symmetry of this path of the soccer ball will be x equals -10. And the vertex will be on this axis of symmetry. So we could go by 1 for the y-axis. So this is your vertex, -10 and +6. So if we connect it, it will be the pathway like this. Okay, so this is a path, and we are going to state the key information, the zeros. Zeros will be the x-intercept, so it's -30 and 10. So this is for the zeros. And y-intercept, we couldn't see it from here, so we could later sub in the x equals 0 and find the y. We need equation for that. Direction of opening is open down. The vertex is -10 and 6. Open down, then we have a maximum at the vertex. It is a y coordinate of the vertex. So question C asks you what's the approximate height when the soccer ball is at 5 meters to the right of the center line. So we need the equation of this path, then we could sub in x equals 5 to find the y value. So the height unknown means you are looking for the y. So from this question, you will see the PQ is given, and we could pick one of these points as xy. So we may just pick the 10, 0 as xy. Then we find the equation. So sub PQ equals -10, 6, xy is one of the point on the graph, but not the vertex. So 10, 0 into the equation, y equals the vertex form, a bracket x minus p bracket squared plus q. So y is 0, a value is unknown, 10 is x, p is minus -10, then squared plus q is 6. So in order to solve for a, we are going to move the 6 to other side by doing opposite operation is -6. So we are going to have -6 equals a times 10 minus -10 is plus 10. So 10 plus 10 give you 20. 20 squared give you 400. So a times 400. Then in order to solve for a, we move the 400 to other side. Is division, opposite operation. Then we simplify it. The lowest form is -3 over 200. So we have the equation for this path is negative 3 over 200 times x plus 10 minus negative 10, then plus 6. The question C asks you when x equals 5, the y equals what? We sub in x equals 5, so 3 over 200, then 5 plus 10, bracket squared plus 6. Then use your calculator, you will find out it is 2.625 meter. So it also means that in order to block this soccer ball, player at 5 meter right to the center line need to jump 2.625 meter, then he or she will be able to block this. So let's do the last example. A parabolic bridge is 40 meter wide and the highest height is 5 meter. Sketch a graph show the problem if the left edge of the bridge passes through the origin. So it means we are going to start from the left of the bridge, and the bridge is 40 meter wide, so we are going to label it by 5. Then we assume that foundation of the bridge is on the ground, so it's from 0 to 40, and the middle of these two x-axis will give you 20, that is your axis of symmetry, and your vertex will be on this line. So this is x equals 20, the vertex it will be 10 and 5. So the y-axis we are going to go by 1. So your vertex will be 20, 5. And we are going to connect it. The bridge looks like this. So you have two x-intercept 40, 0 and 0, 0. So this is your graph. And this is x, the width of the bridge, and this is the height of the bridge. So the important information 0 is x-intercept 0, 0, 40, 0. And the y-intercept is same as your x-intercept. Direction of opening is open down. And the vertex is 20, 5. Is open down, so you have a maximum at vertex equals a y coordinate at vertex. So for this one, because of PQ, the vertex is given, so we are going to use a vertex form again. We are going to sub PQ is 20, 5, and one of the point you could pick 0, 0 or 40, 0. It will give you the same answer into the vertex form. Y equals a bracket x minus p bracket squared plus q. So y is 0, a value is unknown, we want to find it. X is 0, p is 20, and q is 5. So we are going to solve for a. We move the 5 to other side. It's opposite operation. Then we are going to have negative 5 equals a times 0 minus 20 squared give you 400. So we move the 400 to other side by doing opposite operation to multiplication is division. Then we are going to have a equals negative 1 over 80. So now we have the equation for this path is negative 1 over 80 bracket x minus p bracket squared plus q is 5. It asks you for 4 meters to the right of the center line. So 4 meters to the right of the center line will be 24. So x equals 24. It asks you what's this height of the soccer ball. So we sub in x equals 24. into this equation, we have y equals -1/80 times 24 take away 20, then bracket squared plus 5. So get your calculator out, you will have the answer is 4.8 meter. So this is for this question, and you will see once we know the equation, then we are able to find all the, at any points, the height of the soccer ball. Okay, thanks for watching.